Hi, everybody. This is Mr. Rancourt. This is your assignment for um, Wednesday while I'm gone. So you should be getting this paper from the sub. Bear with me one second. I have to focus on this. There we go. And what I want you to do is before we start like answering these questions, we're going to take a little notes on here. We're going to review the 7 main steps of the scientific method. So I'm going to write some things off to the side, and I'd like you to do the same thing. Okay. So let's go back to step 1 of the scientific method, which is asking the question. And all I mean by that is this, is that we notice something. I'm going to write that, notice something, or we become curious about it, or we're curious about how something works in the universe, okay? And all we simply do is we ask a question. As scientists, we write that question out. You might be on a daily basis asking yourself something, like why does the sun always rise in the east and set in the west? Yeah. Why is it when I apply more force to an object, it speeds up? Or does it actually speed up if I apply more force to it? That would be a scientific question. And then the next thing you're going to do is you're going to do a little background research, excuse me, or you're going to collect some info. In this day and age, we can Google things, yeah, using reliable resources. But we're going to see if somebody else has asked this question or answered this question through their own scientific experiment. And the next thing we're doing is we're going to form a hypothesis, which is our educated guess. Remember, we talked about that yesterday, that the difference between a hypothesis and a prediction is a prediction is just a random blind guess, and a hypothesis is based off actual evidence that's been collected in the past. An educated guess, excuse me, based off past evidence. I want you to write that, past evidence. Again, make sure you write all this down. This is kind of like shorthand to the 7 steps. Well, then the next thing you're doing is you're going to test with an experiment, or you're going to test your hypothesis or test your prediction. Yeah. And as you're doing that, you're going to analyze your data. You're going to look at it closely. Because that's what the word analyzing means. Go ahead and circle that word. You're going to look at it closely. You might do this by drawing graphs. You might do this by filling in data tables. And then the 6th step, which is drawing a conclusion, is you're going to decide, and I'm going to abbreviate a little bit this so I don't run out of room. You're going to decide if your hypothesis, HYP period, was true or not. You're going to tell us, or actually you're going to decide real quick if your hypothesis was true or not. If it wasn't, you might run the experiment again. You might run it a couple more times and decide that it, or find out that it's not, and that's okay too. And then the last thing you're going to do is you're going to share your results, or communicate your results. You're going to share them. You're going to tell the scientific community what it is that you found out. So that way, the next time somebody has that same question, they can go back and do their background research and see what you collected. Okay, I'll give you just a second to fill that in. Feel free to hit pause if you need to. Okay, so then the next thing you're going to do is you're going to look down here. Okay, so actually, if you go back at the directions, it says you're going to match each step of the scientific method with its correct description. Well, this is actually a little confusing, so I'm going to actually help you get this started real quick. So what I want you to do, yes, is you're going to line the number up, or you're going to write the number that goes next to this down here. And I know that doesn't make any sense, and so I'm going to show you real quick. Okay? So these are descriptions of each one of the steps of the scientific method. And you're going to notice that these actually look very similar to these. So this should help you line this up with this. So for instance, let's look at number or letter D. It says notice something and turn it into a testable question. Well, if you go up here real quick, first of all, it's using the word question. And you'll notice up here I said notice something or you're curious about something or ask a question. So letter D is a description of step one. And so all I want you to do is put a step one or number one next to letter D. Okay. We're going to do a couple more and then I want you to finish this one. Look at number, um, sorry, the autofocus is on, shifting. Let's look at letter B real quick. Collect information to better understand your question. Well, if you look up here, doing background insert research is also collecting info. And so all I want you to do next to letter B is put a two because that represents a description of step two in the scientific method. Okay. So I want you to finish this because there's one, two, three, four, five, six, seven descriptions, and there's seven steps, and I've already done the first two. Okay, so read each one, find it up here, and then write the number next to it. Okay. Okay, this next section of part B, you're going to practice writing some hypotheses. First of all, when you write hypotheses, it must contain these two words, if and then. Okay, that's kind of like your cause and your effect when you write cause and effect statements. All right, so let's look at number one. I'm going to help you with number one, and then you're going to try two and three on your own. It says a plant is placed in a dark room for 2 weeks. So I want you to think about a prediction that you can make if you put a plant in a dark room for 2 weeks. Well, we know that plants need sunlight, right? So more than likely, if I put a plant in a dark room for 2 weeks, it's probably going to die. And so that might be your prediction. So you're going to start with the word if. And I didn't leave you a lot of room to write here, so you need to write underneath here. Do that, but write small and write neatly. So if I place a plant, if I place a plant in a dark room for 2 weeks, if I place a plant in a dark room for 2 weeks, then I would write or I would predict it will die. It will die. Now, that's not a prediction, that's a hypothesis because we have background information already in our brains that we've learned that plants depend on sunlight in order to stay alive, right? So it's not a blind guess, that is a hypothesis, that is based on past evidence, right? And so that's what we're predicting. And notice I used the word if and I used the word then. And I'm going to put a comma after weeks because that's grammatically correct like that. Then it will die. If I place the plant in a dark room for 2 weeks, then it will die. I'm going to start this next one with you, and then I want you to finish it on your own. You're going to fill in the blank, so to speak. So it says this: you test whether hot water dissolves sugar faster than cold water. What I would start with, obviously, is the word if. If I put sugar in hot water, if I put sugar in hot water, comma, then I'm going to do this. Don't write the blank. I want you to fill it in. And your then statement should talk about if it's going to dissolve the sugar faster or slower than cold water. Okay. So if I put sugar in the hot water, then it will dissolve faster than in cold water, or then it will dissolve slower than cold water. Okay, so I want you to fill that one in real quick for me and put a period at the end of your sentence. Okay. And again, I apologize for not giving you much room. Just do the best you can. Or if you need to, you can always write on the back if you need to. All right, let's look at the next one real quick. You want to know if the size of the paper airplane affects how far it flies. So I'm thinking that if it's bigger, it probably is heavier, so it might not fly as far. So I could either write my hypothesis about that, or I could make it about a smaller airplane. I'm thinking that a smaller airplane would probably weigh less, it has less mass, and so it's probably going to stay in the air longer. So let's write something like this. And I'm going to actually use this space down here because I have a little bit more. If I create a small and large paper airplane, comma, if I create a small and large paper airplane, because you're going to have to do both to compare them, then the smaller will, I want you to fill in the blank, so to speak. Tell me if it's going to fly farther or not quite as far. All right. All right. So do that and hit pause. All right. So I'm assuming that you unpause, obviously, because you hear my voice. So the next part is about identifying the independent variable and dependent variable in this question. Remember, I told you the independent variable is the thing that you change. Okay. And this is exactly the example I used yesterday in class. Okay. Except it says being plant, and I just said a regular plant. So I need you to tell me in this experiment, if I set up an experiment and I want to find out if the amount of sunlight affects how tall a bean plant will grow, what is it that I'm going to change? Okay, that's your independent variable, and I want you to write that in a complete sentence. And you can abbreviate IB with independent variable. The IB or the independent variable is, and I want you to tell me what is it that I'm changing? Am I changing the amount of sunlight or changing the growth of the plant? Think about that carefully and fill in the blank. And I want you to do the same thing here, except with the dependent variable. The dependent variable is what we're measuring. Okay, it's what we're measuring as a result of changing whatever we changed up here. Not to make that confusing. So my question to you is am I measuring the amount of sunlight or am I measuring how much the plant will grow? I almost said the answer, so I'm going to pause there. Okay, so write that and fill that in. Okay, and then after you're done with that, hit pause real quick. I'm going to hit pause too. Okay, and the last thing. So there's no questions here, but the questions to this data table are on the back here. And I don't need you to write a conclusion. All I want you to do is answer questions 1 and 2. And you're probably going to have to do it off to the side. All right, but let's look at this real quick. So this data table says that there's 3 cups, yes, and the temperature of the room increases. Yes, we've got one temperature at 10 degrees Celsius, one at 20, and one at 30. Okay, just so you know, 30 degrees is pretty warm. 30 degrees Celsius is pretty warm. Okay, well, for cup one, that's in a room temperature of 10 degrees Celsius, it takes 45 minutes for the ice to melt in that room. Okay, in cup two, the room temperature is 20 degrees Celsius, so it's at a medium heat, and it only takes 25 minutes for the ice to melt. But cup three is placed in a room at 30 degrees Celsius, and it only takes 10 minutes for the ice to melt. So then all I want you to do is on the back is tell me, first of all, which temperature caused the ice to melt faster? Yes. Okay. And which temperature or what trend did you notice as the temperature increases? So let's go back real quick. So be careful here. It took 45 minutes for cup one to melt at a room temperature or temperature of 10 degrees. So it took longer for cup one than it did cup three. Just because this number is higher doesn't mean that it melted faster. It actually means it melted slower because it took more time to melt. So be careful with that. Okay. And then question two says, what do you notice? As the temperature of the room increases, what happens to the time that the ice melts? In other words, does it take more or less time for the ice to melt? And think about that really logically, because that should make a lot of sense, knowing what you know about ice and heat. Cool? And then when you're done with this, I want you to turn this into the tray. If you don't get this done by the end of class, I still want you to turn it in, and we're going to check it on Thursday when I get back.